This example involves sums of independent gamma random variables. Let's take some time to read the problem and solve it after that. Okay, so let's first start defining the time to failure for the bulb. So the time to failure of the bulb is the sum of the interarrival times of the three spikes. So delta T1 plus delta T2 plus delta T3, because the bulb fails on the third spike, so it's the sum of 3 delta T's. Now each of these delta T's is gamma distributed and they are mutually independent. We are going to use that very soon. So delta Ti is gamma with parameter k and lambda, and that's true for all i's. So I going from 1 to 3. They are independent, they're mutually independent, and for each delta t, the mean is 2 months and the variance is 2 months squared, just to be dimensionally consistent. So this lets us find the value of k and lambda, and we can derive that lambda is 1 per month and k is equal to 2. So that's how I am able to fully define each of these interarrival times, delta t with k equals 2 and lambda equals 1 per month, and they are mutually independent gamma random variables. Now the sum of the gamma random variables, as we saw in a couple of slides back, that the sum of independent gammas is also gamma provided the rate remains the same, which means lambda is unchanged. So now I have Tf being the sum of 3 independent gamma random variables with the same lambda. I can conclude that Tf is again gamma distributed with a lambda as before, and Kf is the sum of the constituent gammas. So it's because all the gammas, if the sum of the constituent k's. So since all the k's are the same, so Kf is 3 times k. So now I have a new gamma random variable Tf with parameters 3k and lambda. So let's find out the mean life of the bulb. So the mean life of the bulb, the mean of the gamma random variable is k over lambda. So in this case it's 3k over lambda, and that is 6 months. So the average life of this bulb is 6 months. And now we need to find out the probability that this bulb, whose mean is 6 months, is going to work for at least 4 months. So P of Tf is greater than 4 months. Let's go back to the basics, the way we defined the CDF of the gamma random variable, which we did a couple of slides back. So 1 minus the CDF of the gamma random variable is actually what we want, evaluated at 4 months. That is given by the sum of few Poisson PMFs. So x going from kf minus 1. So here lambda is 1 per month as before, t is 4 months, kf is thrice k, which is 6, and we need to add these 6 Poisson PMF terms. And if we do that right, then the answer comes to 78.5%. So that's the probability that this particular bulb will work for at least 4 months.